All right, today is September 11th, 2024. Ed puzzle. That's what we're gonna do today. And then the Explorer number one, you see we're gonna get started on that. Never back down, never what? Never give up. So hopefully you're cool with that. You see all the things that we got going on. The Ed puzzle is due today, so that will be the first thing we're gonna do. Hopefully you heard during the announcements we took a moment of silence for September 11th, 2001. I'm not going to get too much into that in this video, but it is a time of remembrance. This may also be a day where people are feeling a little bit more in their feelings or a little bit more sensitive. I was alive in this time. I remember everything that happened that day because it is a significant event because a lot of things happened. But it was a time that I would say like this, after this, even though it was an extremely sad and traumatic event for America, it was a time that we were able to become unified after that, which actually was really awesome. Anyhow, it's just a thing to, again, never forget. We always remember what happened on September 11th. All right, so what I want you to do on this September 11th is finish your Ed puzzle, and then we're going to talk about the metric system. Again, if you're watching online, finish your Ed puzzle, then we're going to talk about the metric system. In class, I'm going to give everyone, 10 minutes. So 10 minutes to finish it. This video is 5 minutes. Okay, so it should take you somewhere around 7 minutes to complete. All right, so let's talk about the metric system for just a couple of minutes. So some of you guys were like, yo, they use that somewhere else, this is not. So we'll just talk about it. So if you actually look at most of this, and again, this is the glue stick, same one you guys have in your thing. If you just look at these things, it's 7 grams, which is metric units, and then 24 ounces. So this is very normal, okay? If you look at this as well, it says it has it in inches, but it also has it in centimeters. And the reason that is because all companies have already switched over to the metric system. It's just in America, we still push out these other units so that way they could sell products in both places, because now they could sell this product in Canada, or they could sell it in America, same product, right? So if you're a company, of course you're going to want to do both. So again, 800 milliliters, but then for the US, we have it, right? 1.69, right? So and then we have some stuff with the 27 point. So this is 1.69 pints, but then you also have 27.0 fluid ounces. Now these are things that people are like, fluid ounces, solid ounces. Most people don't know the difference between them. We'll talk about the metric system a little bit more, but just realize for now that the metric system is used worldwide, right? And so that's why we use it for science, for this purpose. If you take a look at where it's used. So in over here, right, we have in the United Kingdom, it's a little bit mixed. The rest of the world is using all of the metric system. Officially on the imperial, metric and imperial is in use. So they are blended as well, this country here. And then we have a little bit here, right? A little bit is here in America that we are using the imperial system, right? Or the US standard area or customary system. But the majority of the world is already on the metric system. And as far as all our scientists and doctors, if you think about it, like when you get your medicine, the doctors will tell you take so many milligrams. That's already metric. They'll tell you, oh, so many milliliters of such and such medicine, right? So if you go home and you look at like maybe the medicine that maybe was prescribed to your actual like little brother or sister, if you look at the little, that plastic syringe where you draw it out, or you look at those little cups, you'll see they're all already in the metric system. A lot of our measuring cups are like that as well. If you go look at them, you'll see like, oh, it does have ounces, it has cups, but then it also has milliliters on it, because a lot of them are already crossed over for the metric system. So the metric system is heavily in use, and we'll teach you how to read it and how to use it as we go along throughout this year. So just know in science, the main reason we use it, if you look at this map, why do you think is the main reason we use it in science? Hopefully you're saying so we can all speak the same language. That is correct. So we can all be talking the exact same language as it pertains to mathematical and quantitative data, right? As it pertains to data and scientific experiments. The reason we do that is so that we all can verify. So the people in Africa can look at the people in Brazil's data and be like, oh, we're speaking the same language. And the people in America can look at Canada's or Greenland or maybe like the Sudan, right? Or Nigeria or Madagascar or Australia. We can look at these different people and the scientists' experiments, and we can be speaking the same language as it pertains to data. And you don't have to do all this converting. We're going to do a little bit of converting today, and so that way you can get a first-hand experience on what it's like to have to convert between systems. All right, let's get going on to Explorer number 1. So please turn to page number 15, and then I need you to take about 60 seconds or so to read it. If you look, we're going to do part 1 first. We're going to do part 1 first, okay? So just chill. We're going to do part 1. And then we'll move on to part 2. But again, we're going to do part 1. Just read through it real quick and then see where we're at. All right, cool. Okay, so if you take a look, we are now on part 1 right here. So first thing it says, observe your teacher as your teacher does what? What's your teacher supposed to do? Applies force to a bathroom scale, and what is the weight in pounds that registers on the scale? Okay, cool. So that is exactly what we are going to do. So let me get my bathroom scale. I should have had that ready. My bad. Crazy situation happened. The batteries went out as soon as I was trying to do this. So first we're just going to step on it or press on it initially, right? Let's see. Okay, so there. So we get it to 0. Then we're going to go ahead and apply the pressure. So it looks like I'm about 70, 80, 79. Let's see if I can get consistent pressure. Let's see what we got. 103. Let's go with 103. Okay, so let's go with 103. Okay, cool. So 103. I know the highest I saw was probably 108. So let's go with 108. Let's go with 108. I'm going to turn the light back on. So we're going to go with 108. So I'm going to put that scale down. That's the highest amount that I actually saw. Okay, so then let's go ahead and get this thing. Oh, did I not plug in my pencil? Oh my gosh. I got a lot of things going on. Okay, cool. Let's plug in this digital pencil here. Boop. You heard it. You heard the sound. You see we ready now? Okay, we ready now. Okay. There we are. Bam. I think we got blue, which is totally fine. Okay. So observe the teacher bathroom scale. What is the weight in pounds? So it was like about 100, and let's go with 108 lbs. And we kind of talked about that yesterday. 108 pounds. Now convert the amount of weight from pounds to the amount of force in newtons. Remember, 1 pound is equal to 4.45 newtons. You will need this, so remember that. I'm gonna go like this instead of having it like that. I'm gonna go ahead and be like flat out. Let's go ahead and highlight that. That thing is mad important. Okay, so this is called a conversion rate, okay? And how you use these conversion rates, right? Like this is how you use it. What are we trying to convert to? So it says convert to the amount of weight in pounds, or convert the amount of weight from pounds to what? We want to go from pounds and we want to convert to newtons, okay? So that is what it's asking us to do. So we want to convert to newtons. Whatever we want to convert to must go on the top. So 4.45, we want to convert to newtons. So we're going to go to 4.45 newtons. And that's going to be over 1 pound. So it's saying for every 4.5 newtons, there is 1 pound, okay? Because they're equal to each other, all right? So we're going to go ahead and multiply by the pounds that we got. So 108 lb. And that is going to be over 1, okay? So it's over 1. So I just want to make sure we're cool with that. Now here, I'm gonna go ahead and just scroll up just a little bit because I want to make sure that we are good with what just happened there, okay? So I'm gonna write this down is to say this. 108 is equal to, check this out, 108.0. Are you guys okay with that? Hopefully you're good. Those two are the same. Adding this decimal point and a 0 did not change the value at all. Also, this is equal to 108 over 1. Okay? Did that change anything? No, the value of all of these are exactly the same. And some people are like, I don't believe it. If you go ahead and look, I'm going to get my calculator out just so I can show you. So 108 divided by 1 is equal to 108. So there you go. There's the math, right? So just remember, I just want you to know that all of these things are equivalent. This, again, is some math facts that you just need to know. So if you're like, okay, I just figured that out, totally cool. So that's why down here I said 108. Well, that's the same thing as 108 over 1. So sometimes you're going to need that in order to complete a formula or a mathematic problem, okay? So now we need 4.45 times 108. So let's see what that comes out to. So I'm going to go ahead and say, I already have 108 right there in the calculator, so I'm just going to say times 4.45. And that's what I got. So 108 times 4.45. All right, cool. And then I'm going to say is equal to, and that says it is equal to 400. Ooh, I saw 80.6. I'm just going to verify what I saw in my calculator. I just got to make sure. So 480.6, right? And then 480.6 over 1. Now, before we get to the units, we got to see. So we have newtons on top, right? But we also have pounds up here, and this is going to cross cancel. So that's going to cancel there. This is going to cancel there because we have it on the top and the bottom, so we can cancel it out. So what we're left with is newtons right there. So this would be 480.6 newtons over 1. But that is equal to, right? And we just talked about this, 480.6 newtons. Follow me. Okay, so now what I want you to do, you got a practice problem. You got some things that were given to you, right? So we got some stuff there. Please go ahead and do number 3 on your own and see if you can get it. We'll give you a minute. All right, cool. Did you get that done? Did you try? Because here's the thing is, this is like a practice rep, okay? So I'm going to walk through it, but again, this is like a practice rep. So hopefully you said, okay, so imagine a small child is stepping onto a scale. Okay, resulting in a weight reading of 35 pounds. By the way, you should underline that because you know that somehow that's important. How many what? Newtons does the child weigh? So it wants us to go from pounds to newtons. Okay, cool. So if we're using this conversion factor right here and we want to go to newtons, then we need that to be on top. So 4.45 newtons over 1 pound. So we got our conversion factor times, and then what was, 35 pounds, 35 lb over 1 is equal to, so again, we'll cancel the pounds, cool. Now we can just do some multiplication using the calculator. So I'm going to clear this out and then say 4.45 times 35 is equal to 100. And we're going to round this to 1 decimal place. Last time we didn't round, and the main reason we didn't round is because we didn't have anything to round. We already had 1 decimal place, okay? So we'll round it here, and remember, 5 or more, right? 5 or more, it's up the score. 4 or less, let it rest. Let me pause this and see what this. So again, right here, you're going to go ahead and round, right? So that says, so 5 or more up the score. So that means that we go from a 7 to an 8. So it's going to be 155.8. And what are we left with? Newtons, okay? And that's exactly what boom, we are done with the very first part of this. So I'm going to go ahead and take a screenshot of this for my people for later. Ooh, wait, hold on. What we did something wrong. We did something wrong there. Hold on. This and then print. There we go. Bam. Now we got our screenshot. We're good. Okay, so that is part 1. We will actually do part 2 tomorrow. So just check in. The best thing to do though for part 2, right? And so I'm going to make this smaller, is to just read through. So again, read through the rest of everything else. That way you know what's going on and what we're going to actually be doing. And we will talk about this tomorrow. All right, y'all. Peace.